Good morning to everyone. I'm going to the Unit 5 Fuels and Composition. Combustion. Introduction. A fuel is a combustible substance containing carbon as the main constituent, which on burning gives a large amount of heat. During the process of combustion of a fuel, the atoms of carbon, hydrogen, etc. combine with the oxygen with the simultaneous liberations of heat. Carbon plus oxygen gives carbon dioxide plus 94 kilocalories. 2 hydrogen plus oxygen to give water plus 68.5 kilocalories. The main source of fuel is coal and crude petroleum oil. These are stored fuels available in the earth crust and are generally called fossil fuels because they were formed from fossil fuels remain of plants and animals. Characteristic of requirement of a good fuel. It should be cheap and readily available. It should be safe and economical for storage and transport. It should not undergo spontaneous combustion. It should have higher calorific value. It should have moderate ignition temperature. The combustion should be easily controllable. It should have low moisture content because the moisture content reduces the calorific value. The products of combustion should not be harmful. It should have low combustible matter or ash content. Classification fuels. Fuels are classified into two types. Based on the occurrence of fuels are classified into two types. First one primary fuels, second one secondary fuels. Primary fuels it occurs in nature as such. Example coal, petroleum, natural gas. Second one secondary fuel it is derived from primary fuels. Example coke, gasoline, gold gas. Based on the physical state, both primary and secondary fuels may be further subclassified into three types. First one, solid fuel, example coal, coke. Second one, liquid fuel, example gasoline, diesel. Third one, gaseous fuel, coal gas, natural gases. This is the classification of summarized as follows. Fuels are primary or natural fuels, secondary fuels are artificial fuels. Natural fuels is three types: solid fuel, liquid fuel, gaseous fuels. Solid fuel example wood, coal. Liquid fuels examples petroleum oil. Gaseous fuels example natural gas. Secondary fuels are artificial is three types: solid fuel, liquid fuel, gaseous fuels. Solid fuels are coke, charcoal, liquid fuels diesel, kerosene, gaseous fuels coal gas, water gas. Comparisons of solid, liquid and gaseous fuels. It is a comparison property, solid fuels, property calorific value, combustion, control of combustions. Due to ash and moisture contents calorific values is low. Higher calorific values on solid fuels. Highest calorific values than solid and liquid fuels. Combustion slow, liquid fuels quick, gaseous fuel rapid. Control of combustions cannot be controlled easily, can be controlled when required in liquid fuels, can be controlled by controlling air supply in gaseous fuels. Solid fuel. Solid fuel of example coal. Coal is an important primary solid fuel that has been formed as a result of alterations of vegetable matter under some favorable conditions. Qualifications of metamorphism. The process of conversion or alteration of vegetable matter and anthracite is called qualifications of metamorphosis of coal. Classification of coal. Coal is classified in the basis on the rank. The rank or coal is indicated its degree of maturity. Various types of coals: wood, bit, lignite, bituminous coal, anthracite. The progressive transformations of wood anthracite result in first one decrease in moisture content, decreases in volatile content, decreases in hydrogen, oxygen, nitrogen and sulfur content, increases in carbon content, increases in hardness, increases in calorific value. Analysis of coal. This is two types: proximate analysis and ultimate analysis. Proximate analysis of determine percentage of moisture content, volatile matter, ash content, fixed carbon in coal. Moisture content. About 1 gram of powdered coal sample is taken in crucible and it is heated at 100 to 105 degrees centigrade in electric hot air oven for 1 hour. The loss in weight of the sample is found out and the percentage of moisture is calculated. Percentage of moisture is calculated equal to loss in weight of the coal divided by weight of the air tried in coal in 1000. Volatile matter. After the analysis of moisture content, the crucible with a residual coal sample is converted with a lid and it is heated at 950 degrees plus or minus 20 degrees centigrade for 7 minutes in a muffle furnace. The loss weight of the sample is found out, then percentage of volatile matter is calculated loss in weight of the coal. Percentage of volatile matter in the coal equal to loss in weight of the coal divided by weight of the air dried coal into 100. Third one, ash content. After the analysis of volatile matter, the crucible with the residual coal sample is heated without 700 plus or minus 50 degrees centigrade for half an hour in a muffled furnace. The loss of weight of the sample is found if the percentage of ash content is calculated as in weight of the ash formed divided by weight of the air tried coal into 100. Fixed carbon. Percentage of fixed carbon in the coal equal to 100 minus percentage of moisture content plus volatile matter ashes equal to 100 minus percentage of moisture content plus volatile matter plus ash content. Significance of importance proximate analysis. Moisture content, volatile matter, ash content, fixed carbons. Ultimate analysis. It involves the determination of percentage of carbon and hydrogen content, nitrogen content, sulfur content, ash content, oxygen content. Carbon and hydrogen content. A known amount of the coal gives formation of carbon dioxide and hydrogen. Water. Reaction carbon plus oxygen gives carbon dioxide, hydrogen plus and oxygen gives water. K-Bogus tube. The carbon dioxide vapor is observed increases in weight of K-Bogus tube equal to weight of CO2. Anhydrous of CaCl2 tube H2O vapor is observed increases in weight of calcium CaCl2 tube equal to weight of H2O. From the weight of CO2 and H2O, percentage of carbon and hydrogen is calculated. Percentage of carbon, 12C plus O2 is equal to CO2 14. 40 grams of carbon dioxide contains 12 grams carbons. Therefore, calculated carbon dioxide content gives 12 into 4 divided by 44 gram of carbon. The percentage of hydrogen also same. Hydrogen plus oxygen gives water. 18 grams of water contains 2 grams of hydrogens. It's calculations. Nitrogen content also. Gazettal methods. Powdered coal reacted with the concentration of sulfuric acid presence of K2SO4 catalyst to form ammonium sulfate is a clear solution in presence of sodium hydroxide to the ammonia and then reacted with standardization of N divided by 10 HCl to form neutralization takes place. Reaction 2 ammonia reacted with 3 hydrogen plus H2SO4 gives ammonium sulfate. Ammonium sulfate reacted with 2 sodium hydroxide to form 2 ammonium plus sodium sulfate plus water and ammonium plus hydrochloric acid to form ammonium chloride. From the volume of HCl is consumed, percentage of nitrogen is calculated. Percentage of nitrogen equal to 1.4 into volume of acid consumed into normality divided by weight of coal taken. Sulfur content also same. From the weight of the known amount of the coal burned in bomb calorimeter and sulfate is formed. Extract with water to form extract only and barium chloride is added. Barium sulfate is formed. Barium sulfate is and then filtered and tried weighed. Calculation let of the weight of the coal sample equal to m grams. Weight of the barium sulfate is obtained equal to x grams. So sulfur reacted with 2 oxygen to give sulfur dioxide and barium chloride is adding to barium sulfate is formed and 233 gram of barium sulfate contains 32 grams of sulfur. Therefore, x gram of barium sulfate is contained equal to 30 into x divided by 233 gram of sulfur. Percentage of sulfur in coal equal to 32 into weight of the barium sulfate is obtained divided by 233 into weight of the coal into 100. Ash content also same. Is a volatile matter in coal equal to loss in weight of the coal divided by weight of the air divided into 100. Oxygen content equal to 100 minus percentage of carbon plus hydrogen plus sulfur as content. Significance and importance of ultimate analysis. Analysis carbon and hydrogen. Significant increase in calorific value of the carbon helpful in the coal. Nitrogen no calorific value. Good quality means low nitrogen content. Sulfur increases in calorific value. It produces SO2, SO3, and corrosion takes place. Oxygen low calorific value. Good quality means low oxygen content. Carbonization. When coal is heated strongly in the absence of air, called destructive distillation, it is converted into lustrous, dense, porous, and coherent mass known as coke. This process of converting coal into coke is known as carbonization. Caking coals and coking coals. When a coals are heated strongly, the mass becomes a soft plastic and fuse to give a hornet mass. Such type of coals is called caking coals. But if a mass of the produced is hard, porous and strong, then coals are called coking coals. Coking coals process lower volatile matter and are used for the manufacture of metallurgical coke. Thus, all the coking coals are caking coals, but all caking coals are not coking coals. Metallurgical coke. When bituminous coal is heated strongly in the absence of air, the volatile matter escape out as mass become hard, strong, porous, and hornet, which is called metallurgical coke. Acoustic or characteristics of good metallurgical coke: purity, porosity, strength, calorific value, combustibility, reactivity, cost. Purity. The moisture as sulfur and porous content in the metallurgical coke should be low because moisture and ash reduce the calorific value. Sulfur and phosphorus may contaminate of the metal. Porosity. Coke should be highly porous so that oxygen will have limited contact with the carbon and the combustion will be complete and uniform. Strength. The coke should have very high mechanical strength in order to withstand high pressure of the overlaying material in the furnace. Calorific value. The calorific value of the coke should be very high. Combustibility. The coke should be burned easily. Reactivity. The reactivity of the coke should be low because the reactive coke produce high temperature in combustion. Cost. It should be cheap and readily available in the market. Manufacture of metallurgical coke. There are so many types of ovens used for the manufacture of metallurgical coke, but the important one is auto oven by product oven. Auto oven by product oven method in order to increases the thermal efficiency of the carbonization process and recover the valuable byproducts like coal, gas, ammonia, benzoyl oil, etc. Auto oven developed modern by product oven. In the diagram of auto oven by product, it is a auto oven method. It is a thordine, ammoniadine, naphthalene, benzene, and hydrogen sulfide. And finally, gold gas is evolved. The oven consists a number of silica chambers. Each chamber is about 10 to 12 meter long, 3 to 4 meter height, and 0.4 to 0.4 m width. Each chamber is provided with a charring coal at the top. It is also called provided with a gas offtake value and iron door each end for discharging coal. Coal is introduced into the silica chamber and the chambers are closed. The chamber is heated into 1012 degrees centigrade by burning in the superheated and air producer gas. The air gas superheated sending through second to three hot regenerators. Hot flue gases produced during carbonizations are allowed to pass through first and fourth region up to 1000 degrees centigrade. For economical heating, the directions of the inlet gas and the flue gas are changed frequently. The above systems of recycling the flue gases produce heat energy is known as the regenerative systems of heat economy. After 24 hours, when the process the complete in the coke is removed and quenched with water, the yield of coke is about 70%. The valuable byproducts like coal gas, tar, ammonia, H2S, and the benzoyl, etc., can be recovered from the coal gas. Recovery by water Hoffman products: tar, ammonia, naphthalene, benzene, hydrogen sulfide, and gaseous fuel. Recover tar by sparing liquid ammonia to dissolved tar, ammonia, and again recovered by the heating the solution. Ammonia by sparing water, here ammonia gets converted into ammonium hydroxide. Naphthalene, by sparing cold water, naphthalene gets condensed. Benzene, by spraying petroleum, benzene gets condensed liquid. H2S. The remaining gases are then passed through the effluvial packet with moisture Fu2O3. Here H2S is retained. Gases fuel. The final gases left total is called coal gas which is produced. Advantages of auto open process. Valuable byproduct like ammonia, coal gas, naphthalene, etc. were recovered. The carbonization time is less. Heating is done externally by producer gases. Liquid fuels in form of the petroleum. Petroleum or crude oil is naturally occurring liquid fuel. It is dark brown or black colored viscous oil found deep in Earth's crust. The oil is usually floating over a brine solution and above the oil natural gas is present. Crude oil is a mixer and then paraffin, olefin and aromatic hydrocarbons with a small amount of organic compounds like nitrogen, oxygen and sulfur. The average composition of crude oil is follows constituents carbon, hydrogen, sulfur, nitrogen plus oxygen in percentage of carbon 80 to 87 percentage, hydrogen 11 to 15 percentage, nitrogen sulfur 0.1 to 3.5 percentage, nitrogen plus oxygen 0.1 to 0.5 percentages. Classification of petrol: paraffinic based type of crude oil, naphthenic and arsenic of base type of crude oil, mixed base type of crude oil, and then refining of petroleum crude oil. The crude oil is obtained from the earth's mixtures of oil, water, and unwanted impurities. After the removal of water and other impurities, the crude oil is subjected to fractional distillation. Thus, the process of removing impurities and separating the crude oil is into various functions having different boiling points is called refining of petroleum. The process of refining involves following steps. Steps 1: separations of water, Cottrell process, removal of harmful sulfur compounds. Step 3: fractional distillation. First one, separation of waters already Cottrell process. Second one, steps 2, the removal of harmful sulfur compounds. Sulfur compounds are removed by treating the crude oil is copper oxide. The copper sulfate formed is separated by out of filtration. Third one, fractional distillation. The purified crude oil is then heated about 400 degrees centigrade in an report where the oil gets vaporized. The hot vapors are then passed into the bottom of the fractionating column in figure. The fraction column is tall cylinder tower containing a number of horizontal stainless steel trays to a short distance. Each tray is provided with a small chimney covered with a loose cap. When the vapor of this oil go up in the fractioning column, they become cooler and get condensed at different trays. The fractions having higher boiling points condense at lower trays, whereas the fractions having lower boiling points condense at a higher trays. The gasoline obtained by this fractional distillation is called straight run gasoline. Various fractions obtained at trays are given in table. Name of the fractions, boiling range of degree centigrade, range of the carbon atoms uses, uncondensed cases, and petroleum ether, gasoline or petrol. Heavy oil or refraction gives. Name of the fraction, lubricant oils uses as lubricants, petroleum jelly or vaseline used in medicines and cosmetics, greases used in lubricant, paraffin wax used in candle, boat, policy, etc. Pitch at above 400 degrees used for making roads, waterproof roofing, etc. Synthetic petrol. The gasoline obtained from the fractional distillations of the crude petroleum oil is called straight run petrol. As the uses of gasoline is increased, the amount of straight run gasoline is not enough to meet the requirement of the present community. Hydrogenation of coal or manufacture of synthetic petrol. Coal contains about 4.5% of contains compared to about 18% of petroleum. So coal is hydrogen is deficient compound. If coal is heated with hydrogen to high temperature and high pressure, it is converted into gasoline. The preparations of liquid fuels from solid coal is called hydrogenations of coal or synthetic petrol. An important method available for the hydrogenations of coal is Perkius process in direct method. Perkius process or direct method. In this process, the finally powdered coal is made into a paste with a heavy oil in a catalyst powder is mixed with it in. The paste is pumped along with hydrogen gas into the converter where the paste is heated at 450 degrees centigrade under the pressure of 200 to 15 atmosphere. During this process, hydrogen combines with the coal, the uniform saturated higher hydrocarbons, which undergo further decomposition at a higher temperature to yield mixture of lower hydrocarbons. The mixture of is led to a condenser where the crude oil is obtained. The crude oil is the fraction yield to gasoline, middle oil, heavy oil. In this process, the finally powdered coal is converted into a paste with heavy oil catalyst powder mixed within it. The paste is pumped with hydrogen into the converter. I'm already telling. The crude oil is fractional. The middle oil is further hydrogenated vapor paste to yield more gasoline. The heavy oil is again used for making paste with fresh coal dust. The yield of gasoline is about 60% of the coal used. The Bergius process diagram. The middle oil is further hydrogenated vapor process yield more gasoline. The yield gasoline is about 60% of the coal used. Knocking. Knocking definition is the kind of the explosion due to repeat pressure rising occurring in the IC engine.